closed and all that kind of stuff. So, I think a lot of the students are probably just gone home. I'm doing my class in person, but I'm going to record it. I'm just, yeah. And it gave me a chance to come in and do work anyway. So, it's quiet and that. So it's kind of nice. You know, it's like I could do my Zoom from home for just Zoom for my UCS class, which is later today. It's not until like 5 o'clock. And I'm like, if I come in here, I'm going to get work done. So, and I brought food. So, because I knew there's not going to be any food on campus. Oh, got to turn on the heat. At least there's heat. But sure, many of the students just like gone home. And the next week is Thanksgiving. So we will have class on Tuesday, but of course not Thursday. And I think schools should at least, universities where they have, or any college university that has on-campus housing and students, maybe they just should start closing the canceling class, having that week off of Thanksgiving, because everybody here, goes home for Thanksgiving week. Even if they live in San Jose, they go home. They're gone for the whole week. And although it's not supposed to be until Thursday or Friday. Am I sounding old? Right? Sorry about all this goodness writing at the beginning. I just seem old. It's like, what's this whole Zoom thing? Everybody leaving, and in my day, I was not the best student, so I understand. But I worked like a lot of them and a lot of you. Yeah. And I worked 32 hours a week while I went to school full time. Yeah. So that, like a lot of us, somebody had to pay for it. All right. How are you all doing? How's everybody doing?
Good, thanks. How are you?
Good. Oh, I don't know. I hope I'm not like I'm complaining.
You don't sound old, Rick. You don't. It's light. It beats us up sometimes.
Yeah.
I don't know. Sometimes I feel, I knew what kind of student I was. I'll tell you, I'll be honest with you all. I was not the best student. I did what I could to get through my classes. I wasn't sure what I was interested in. I wasn't sure what I was going to do. Um, you know, um, I enjoyed learning a whole lot more when I got out of school. Then it took off. I couldn't learn enough because it was all the sudden became fun. It wasn't assessments, it wasn't exams, it wasn't grades, it wasn't being called on in class. It was about learning. It was about the world was open. My job was open book, open notes, help each other out. I thought this was amazing. You focused on what your job was, not 5 different classes, and they paid you. It just made it for me a lot more interest. I got interested in stuff that I didn't really care about in college. All of a sudden now, I couldn't get enough of. I sometimes wish there was a way we could take that um, in education and do that, from the real world. I don't know how to do that though. I try and do it, just try and make it relaxing and informative and that's the best I can do. All right. Well, let's get on with today's subject. Today we are going to talk about DHCP for IPv6. But before we do that, I had this mind bender. It's like, Rick, why don't you overcomplicate things sometimes. Let's just take a look at that. Remember, we talked about SLAC, stateless address auto configuration. And let's simplify it. Instead of Rick talking about, little animation here. Maybe this will help. So here we have a computer. We're talking about those temporary addresses. Those temporary addresses are the ones that the client uses when it initiates conversation to the outside, the connection to the outside. Okay, so first of all, it's going to create that address from the router advertisement. It gets the prefix, and along comes with that, so it'll create an address from the, and use the prefix and create its own address. Again, and I thought, Rick, why not just make it simple? All A's, okay? So, oh yeah, that I can see. Okay, there's also a valid lifetime and a preferred, I'm sorry, a preferred lifetime with this, and also a valid lifetime. So the valid lifetime is the preferred plus the deprecated. So we'll see that in a moment. So the host gets this, the client gets this router advertisement, creates with the prefix, creates its own address. Okay, so what's it going to use this for? Well, for connections that it initiates, okay, like going to Netflix. So there it is, going to Netflix, has the connection going. Meanwhile, you know, it's using it for different things, and this depends really on the operating system when all of a sudden it says, okay, you know what, this has been long enough. And I can do this given the preferred lifetime in the RA. I can use that timer. I can use my own time. So how long I'm gonna keep this preferred, meaning I'll keep new connections. But it says at some time I'm gonna deprecate this. I don't want to use this temporary address forever. And it's ultimately up to the operating system. And so what it's going to do is says, well, you know what? I'm still using this address though. So I'm not going to get rid of it. So the preferred lifetime has expired, but it's still using this address to connect to something. Let's say it's connected to Netflix. Okay, it is still using this address. So what it says is because I'm still using this address, I'm going to move it to deprecate. Okay. And I'm going to keep this going as long as I'm using it. Okay. Meanwhile, I'll create a new preferred address for any new connections. Now, what I'm showing here is it's still using this Netflix address, right? This one here to go to Netflix, okay? Or whatever it was using for it before, from when it went from preferred to deprecate, meaning it was still in use. So I'm not going to get rid of it. Don't want to just close that connection. But meanwhile, I created a new preferred address, and I'll use that for any new connections, okay? For new connections, like going to Zoom, okay? And this is the one I'm going to use. Now, this is my preferred one. Any new connections, as long as this is still preferred, this is what I'm going to use. I haven't gotten rid of this because I'm still connected to, in this case, Netflix. Or what, as long as I'm using it for something, I'll keep it, okay? But at some point, you know, we're going to log off Netflix. We're not going to need it anymore, okay? And once this address is no longer being used, it becomes invalid and gets removed. Does that make sense? Does that help a little bit? That's the preferred and deprecated. So there's many times you may not ever see something deprecated, okay? And the reason why is it's no longer being used. It was preferred and no longer being used. And, you know, you might have logged out, you might have gone home and your computer got a new preferred address and it just never needed never had, well, I won't go that route, but I talked about the, you know, if you go away for a while, come back, the deprecated time, this valid lifetime expires, so well, I'll just create new addresses. No problem. Okay, let me do that one more time, just so we're clear on this. Okay, so the router advertisement is sent. The device creates a preferred address, actually uses the prefix in the router advertisement. There's creates its own interface ID, sets a preferred lifetime. Says, you know, I can create, anytime I make a new connection for a certain amount of time, and it's up to the operating system, I'm going to use this address. Okay. At some point, you decide to go to Netflix. Okay, it's going to use that address. And anything else you're going to, it's going to use that address, one address. Netflix, listen to Spotify, doing Google, Facebook, Instagram, I don't know, whatever. It's using that address, okay? Now, this time is going to at some point expire. It's gonna be, so it's being used at some time, this preferred lifetime is going to expire. Okay. Now, what it says is, okay, is anything still using this address? Is anything still using it? Okay. Because if anything is still using it, I'm gonna make it deprecated. So that way that device can still use that, the device can still access whatever it's connected to. But I'm gonna create a new address for, for new connections. Okay. And maybe there's no new connection for a while, but eventually, of course, you're gonna do something else. And says, oh, okay, got a new connection here. We're gonna use that new preferred address, or the one, the preferred address. Again, at some point, so it's for everything that you do now, it's gonna use this address. This one's just a hang me on. For Netflix or anything else that had been using it when it was preferred. But at some point, those are gonna go away. And when those go away, so does the deprecated address. It becomes invalid and it goes away. Yeah. So that's preferred and deprecated. So there's sometimes you see deprecated, sometimes you don't. It just depends on whether or not that there was an existing connection that still needs that address. Yeah. If there's no existing connection, it will go from preferred to invalid, meaning like you turned off your computer for a while, those will eventually go to invalid. Reconnect, turn on your computer. It says, oh, I give myself a new preferred address. Everything is new now. There was nothing still connected. All right. That's what I did last night and this morning. All right. So let's talk a little bit about DH. Oh, I'm using an older presentation here. It's an oldie but a goodie. So DHCPv6. Okay. So this little chart here, not to confuse you. This is showing how devices get global unicast address. Yes, you can configure it statically. You can do that on your computer. Don't worry about IPv6 unnumbered. Ooh. And don't worry about static and EUI64. Okay, but you can create a static address. Some of this is just hang-me-ons from years ago. Dynamic addressing. We saw Slack. Okay, today we're going to see how to use DHCPv6, both stateless and stateful. When the PD is prefix delegation, I'll talk a little bit about that. I think I'm going to talk about that on Tuesday. Okay. So in IPv4, okay, we just, uses a stateful server. Okay. This server assigns everything. And by the way it maintains state is it when this device is sending the discover, so it's a DHCP discover message, a DHCP offer message, a DHCP request, and a DHCP acknowledgement. That's the four messages sent in between the client and the server. The server is actually we call it binding the address it assigns to this client, in this case 10.1.1.101, that specific IPv4 address using the client's Ethernet MAC address. That's how it knows, hey, this client got this IPv4 address. All right, so we saw that in a router advertisement message, there's actually three main flags. There's the A flag, auto configuration flag. That tells the device, hey, create your own address using the prefix in the router advertisement. So Cisco iOS, this flag is off by default. Or the O flag and the M flag. Only the A flag is set. And that's what we're going to focus on today. On Tuesday, I'll talk a little bit about the Comcast router. And I'll also, at home, which is a little different, and also talk about prefix delegation. If you want the device to get stateless information, meaning I mean, you're gonna use Slack to create your own address, but maybe the DHCP server has other information we would like to provide, it would like to provide you, like I'm not gonna give you the DNS address, I'll let the stateless DHCPv6 server do that. Okay, then you'd set the O flag. The M flag is still off at this point. Now, if you want you want the devices to get its IPv6 address from a stateful server, then you got to set the M flag to 1. So we're going to start off with stateless, just so you know what that is. I don't think that's, well, yeah, it's still used. It's just an option, another one of those knobs. So let's get started here. We're going to look at these two options today. Okay. So again, remember the A flag, that's what tells the device, hey, create your own, oh, I moved it over here. Create your own address by default. You can have the A flag and the M flag set. And we'll see that, I'll show you an example on Tuesday with my Comcast router. My Comcast router at home has the A flag set, create my own address, and has the M flag. The M flag says get an address from a DHCPv6 server. We'll see that my Comcast router at home does that, okay? But we'll see that typically Cisco iOS, and that's the example I'm going to use today, we're going to set this to 0 so we don't confuse things. Don't get your address from Slack, just from a stateful DHCPv6 server. So I think we should talk about briefly here why we would want to do this, why we want to set the O flag, the A flag to 0 and the M flag to 1. Why would we want a device to get its address from a DHCPv6 server not created itself? Usually home networks, we don't care. You don't really care. It's your network. You're not managing a whole bunch of clients out there. In a enterprise network, you may care. You may not, but you may. What do I mean care? You may want to know which devices are getting which addresses. If there's an issue with an IP address on a client device, it's originating something that you don't like, you're suspicious of, it's got sending out some kind of malware or the source of some kind of spam. And it may be something the client doesn't even know it's doing. I'm not saying this is an issue with the person, it just might be their box. And it may not be even anything malicious, it may be just some other issue. But you see that IP address and you want to track it down who has that IP address. That's more difficult to do with Slack. There are ways you can do it, okay? If the device is on, it makes it a lot easier to track who has that device, who has that IPv6 address. But if the device created it itself, it's stateless, okay? So remember, stateless means nobody's maintaining state who has that address. Only the client knows. Now, there's other ways you can track it, maybe with MAC address tables on switches, finding the MAC address and doing some ARP stuff. But if you really want to track who has it, that address, then you're going to use stateful DHCPv6, managed. So let's, this here is, I was not going to show, but I just want to show you, this is the, in IPv4, I need to go here. In IPv4, the way it works is we have DORA in IPv4 for DHCP for IPv4. I just put DHCPv4. Okay. What we have in DHCP here is we have a discover message. Okay. Then we have an offer. by the DHCP server. And we can get more than one offer, by the way. We have more than one DHCP server. Talk about this in CIS 82, about how we can mitigate threats when we have a rogue DHCP server out there, somebody that's pretending to be a DHCP server. So we could then, so we have the offer, so the discover goes this way, the offers come in, this is DHCP for IPv4. Then we send the request. So it's the same here, the request. And we'll talk about it in IPv6 here. And then we have the acknowledgement from the server. So this is DHCP v4 in blue. In IPv6, it's similar, okay? But it is called something different. It's called a solicit message. That this is the device saying, who out there is a DHCP server? I need information. The DHCP server sends back an advertised message, like an offer, saying, I'm a DHCP server. I'm offering you this information. The client says, oh, okay, I like you. I'd like to request that information that you're offering, just like I'd say as an IPv4 terminology. And the server sends back a reply saying, I'm letting you know, I'm replying, acknowledging, I'm replying that I'm assigning you that information. So it's very similar, they just call it different terms. Okay. So let's look at Slack with DHCPv6. Okay, so the router, so when the client connects, it sends out a router solicitation message. Hey, who out there is an a IPv6 router? Send me a router advertisement. The router sends out a router advertisement. Let's say it has its A flag set to 1, O flag set to 1 also, but the M flag set to 0. It says, okay, all right, well, you have the A flag set to 1, the O flag set to 1, but that M flag is set to 0. So what I'm going to do is this. I'm going to create my own address using Slack. I'm going to use your IPv6 address, the source address, the router advertisement as my default gateway. But you're telling me that there's other information. That's what the O flag is, other information from a stateless DHCPv6 server. So after I'm done creating my own address, there's that solicit. Hey, who out there is a DHCPv6 server? I need information. Hey, I'm a DHCPv6 server. Here it is. Okay, here's that stateless information I'm offering. Great, I would like that stateless information. There it is. All right. So first of all, on Cisco iOS, which is the focus of what we do because that's one of the devices, we're thinking about enterprise networks. This interface here, if we want to set the O flag to 1, we say on that interface, IPv6, ND for neighbor discovery, other config flag. That sets the O flag to 1. By default, Cisco iOS has it as a 0 off. Okay, so here's our router advertisement message now, coming from our link local address, going to all IPv6 devices, advertising the prefix length. The auto config flag is set to 1, but now we've set the O flag to 1. This device will say, okay, great, prefix, I know what prefix I belong to, and prefix length, address auto configuration flag. I will create my own address. Okay, so it creates its own address, either using EUI64, but hopefully random. Okay, and that's because the A flag is set to 1. However, it says, oh, wait a minute. So any other information in here, I'm taking, whatever else you gave me. But I notice you have this other config flag set to 1. Well, I don't know what that's about, but I do know what you're telling me is I need to communicate with a stateless DHCPv6 server. So I'm going to go talk, after I've gotten all this information from you, I'm gonna go contact, do that solicit, etc., advertise all that. Hey, who out there's a stateless DHCPv6 server? I need information. Maybe it's DNS. Maybe that's, we're getting the DNS addresses from a stateless server. So stateless means this is information that this server is providing to our clients, which is the same. It's stateless. It's not, it's information that it's not going to keep track of. It's generic information. It's information it gives out to everybody. This client is nothing special. I'm going to give you a DNS address that I give to everybody. Okay, so these are the steps I'm going to show you. It's easier to show you an example, but these are the configurations that we're going to be doing here. I'm going to show you the actual configuration. It's easier than just showing you the command syntax. So let's say we have a DNS server out here, okay? 2001 DB8 Cafe 955. In our router advertisement message, we're sending the A flag to 1, O flag to 1, M flag 0, the default. Okay, it's going to create its own IPv6 address. Then it's going to get information from its DHCPv6 server about something else, like, oh, maybe the address of this DNS server. We're going to configure our router. Our router is an IPv6 router. So it's sending the router advertisement message. We're also, yes, we can configure our router to be that stateless DHCPv6 server. Since this is a enterprise networking class and we're using Cisco as our example, I'm gonna show you how to make this router a stateless DHCPv6 server. And here it is. All right. So first of all, let's just go step by step here. This command here is what makes this a IPv6 router. And using this command also says, I'm going to send out the router advertisement message out. And basically what that command does is says, I'm sending out this router advertisement message out all my Ethernet interfaces. It'll be different out each interface. Out this interface, it's advertising this network prefix and prefix length, and its link local address as the default gateway. Now, we're going to change this router advertisement slightly to set the O flag to 1. Now, the way we do that is down here on gigabit 00 interface. Okay, now notice we have a global unicast address. We have a link local address on this interface. The link local address that's what's going to be used as the default gateway by this device and any of our clients. But notice we've done this. IPv6 ND, neighbor discovery, other config flag. That sets the O flag to 1. Okay. Now what that's going to tell the client is, hey, after you create your own address using the prefix, and this is the prefix I'm going to send you, and the prefix length. These are the prefix, 2001 DBA Cafe 1 : that's the prefix. This is my address. I'm not going to send you that. I'm just going to tell you the prefix length. You're going to create your own address. You're going to use this as your default gateway. When you're done, go talk to a DHCPv6 server. Okay. Oh, by the way, when you say, hey, who out there's a DHCPv6 server? Hey, that's me. I'll be a DHCPv6 server also for you. You don't know it's me. You don't really care. Okay, but I'll be that DHCPv6 server. Now, this says, so when this here says, I'm a DHCPv6 server on this interface. So what that means is when I get those requests, okay, hey, who out there's a DHCPv6 server on this interface, gig 00, I'm listening to that. Okay, IPv6 DHCP server means I'm acting as a DHCPv6 server on this interface for anybody that needs that. This here, IPv6 stateless, notice it's in all uppercase. That connects to this here. IPv6 stateless, IPv6 stateless. So it's best practice anytime. This is like, think of it like a variable, if you know what variables are. But this is associated with the name that we gave it. There's no parameter in Cisco iOS that looks like this. We do it in uppercase to make it something, hey, this is something Rick named. This is something we created, IPv6 stateless. So it finds this under IPv6 DHCP pool, and this name is associated with this here. So it says, okay, when anybody is looking for IPv6, any device is looking for a DHCPv6 server, hey, who out there's a DHCPv6 server? Okay, we're gonna say, yeah, we are, and here's the information we have. What we're gonna provide is this. Whoops. We're gonna provide them back this DNS server address and this domain name, and that's it. Okay. Notice that there's nothing in here that's giving them an address. We're gonna send back a DNS server address and a domain name saying this is the domain you're on, this is the DNS server address you can use. Okay, so once again, we send out the router advertisement message, the router did, okay? The included a prefix length, and our link local address is the source address as the default gateway. So this client got this information from the router advertisement message. It got the prefix, created its own interface ID, and as far as the default gateway, that was also in the router, that was the source IPv6 address of the router advertisement. I should have put that in here. FE80 : 1. So this all came from the router advertisement. But we had the O flag set to 1. So this client said, hey, who out there's a DHCPv6 server? Well, our router was acting as that. And this information here actually came from the stateless DHCPv6 server. Okay. Does that make sense? Any questions on that?
Rick,
Yeah.
again, this is where like I'm trying to track and I'm realizing things are communicating with each other and they're taking what they need. But again, this is not to be too concerning if it's not 100% crystal clear.
Right. Yeah. So, but I love it when you ask these questions. Okay. So let me just mention this. So what happened was this is sending out the router is sending out the router advertisement. Okay. And that contains just this prefix here. Okay. Now the A flag is also set to 1. So I should put this in here too. That's the default. This device, just like we saw all last week and previously, when it sees that A flag set to 1 and it contains the router advertisement, contains all of this. Oh gosh, darn, Rick. This is, boy, I noticed after years of seeing the same thing, I should have double colon there. There's the prefix. There's our network. And excuse not having the double colons there, but there's our prefix and prefix length. The device uses this and creates its own interface ID. Okay, does that make sense?
Yeah, that's helpful. Thank you.
Okay, yeah, I'm going to continue here. I'm going to keep on. So, but there's something that was because of the A flag. But it said, hey, there's an O flag set to 1. So the device said, okay, I created my own IPv6 address. And by the way, your default, this was sent from your FE80 : 1 link local address. So I'm using you as the default gateway. Okay. Now, it said, oh, I see you have this O flag set to 1 here. So what I'm going to do with that is I'm going to say, hey, who out there's a DHCPv6 server? I need something. I don't know what it is, but this O flag's been set to 1. I've been told I need to go look for a stateless DHCPv6 server. Now that could be a server on any server on this network here could act as that. Okay, you could have a server, a DHCPv6 server doing this. Okay, responding, but we don't. The router is going to be this DHCPv6 server. Okay, and it says, yeah, I've got other information for you that I give out to everybody. It happens to be this DNS server address and this domain name. So let me give you this. It says, oh, okay, great. Now I got that. It happened to get them both from the router, but the router's wearing 2 hats. First hat is the router's acting as just an IPv6 router, sending the router advertisement. The other hat it puts on, which the client doesn't know or care, is it's acting as a stateless DHCPv6 server. Now, in this case, is there any reason why this information could not have been included? So in just the router advertisement message. No. This same information could be included in a router advertisement. Why wasn't it? It just may be something, there were times when early on that clients didn't accept this information in a router advertisement. It had to come from a DNS server. So some of this goes back a ways. So Slack or using the O flag is something probably less common. Okay. Now everything can pretty much be sent in that router advertisement message. We don't have to ask for a stateless DHCPv6 server to give us things that the router advertisement didn't include. Just to finish this up, and then we'll take a 5-minute break and talk about stateful. Just so you see what it would look like when you have and again, I should put, and this is my fault, the A flag is equal to 1 by default. When we have the O flag set to 1, meaning there's a stateless DHCPv6 server out there, okay, what you will see when you do show IPv6 interface and this specific interface, we saw it's all the IPv6 addressing information on this interface. This host use stateless autoconfig for addresses. That means the A flag set to 1. Whenever you see a host use, this is Cisco iOS telling you its A flag is set to 1. When you see host use DHCP to obtain other configuration information, that means it's set the O flag to 1. That means we did that. So this is the A flag, this is the O flag. So this is saying the A flag is set to 1, this is saying the O flag is set to 1. If we looked at the actual router advertisement message, we could see the O flag has been changed to 1. Continuing with this, we see the A flag is also still by default set to 1. By default, the on-link flag is always set to 1. That's saying that this prefix, let's look at this here. This prefix here, so this A flag is telling the host, create your own address using this prefix and prefix length. The L flag, by the way, is saying, that's just a nice way of saying, by the way, this is the network you belong to. This is your network. Whoops. We're gonna get into stateful DHCPv6 here in a moment, but remember I mentioned, this is just a little side extra stuff with IPv6. Remember on a DHCP for IPv4, it uses your MAC address to keep track of, the DHCPv4 server binds the IP addresses it allocated with the MAC address of the client. It doesn't do that with IPv6. Okay, what it does is it creates something called, on your computer has a DUID. Oh, isn't that more stuff? A DHCP unique identifier. So every computer will have an identifier. And what it does, it says, okay, it's just trying to be more specific. It says, I'm going to bind it to that identifier with your IAID. Okay, it's similar to a MAC address. So when you do ipconfig /all on your computer, oops, here is your computer's DUID. Look at that long address. Isn't that horrible? And here's that interface that is specific to that DUID. Basically, this is how the server is binding you to that address. Think of it like a MAC address, okay? And that's all I'm going to spend on that. I don't need to go in more detail on that. Let's go to this next. We're going to go take a break here. So basically, when you see this stuff here in IPv6, it's just that's what this is on your computer, and this is what the server is binding the address it allocates to you. We're going to do that next. To the address it's going to allocate to you. So I kind of got ahead of myself, but not really. Now we're talking about stateful DHCPv6. I should have moved that up there. Okay. This is how, when it binds the address it's going to provide to you, it's going to do that using this special DUID, which is your computer, and IAID, which is the interface. It's basically just says, I'm going to give you an address and keep track of you based on this information. Why did they make it more complicated? I wonder this. They really didn't need to. Again, just trying to, in some ways, they went a little overboard on IPv6. They made it more complicated they did this for, let's just give more options, okay? And in some ways that's good, but in some ways, this overcomplication, these more options, just made it more complicated for people. They didn't want to lock themselves in to, oh, darn, what if we would have allowed, not just the device's MAC address, but, a specific address on the device and a specific address on that NIC card. I don't know, made it more complicated than they needed to. So when we come back, that's where we're going to start. We're going to talk about the using stateful DHCPv6. So let's take 5, and I'll pause the recording here.
Recording stopped.
Take 5 minutes, and then we're going to get to the real DHCPv6, which is stateful. It's right here. I'll give you 6 minutes.
just me. The players themselves are noticing. Even a fellow LA native, like Cooley, pretty closers, told me earlier this week, you can feel it, not happening. Well, you know this. Growing up in LA as a sports fan, you understand, it's a different sort of town, right? I'm from LA too. It's a great town, but if you don't win, you know how the fans are, man. They will find something else to do. I can even make the argument that winning's not enough. You have to win a certain way. The fact the Chargers are breaking through and creating their own
Oh.
Recording in progress.
All right, thank you, thank you, thank you. Everybody reminded me to start the recording. All right, so let's talk about the router as a stateful DHCPv6 server. So typically, once again, you can either you can use Slack, let the device create its own, or you can have a stateful DHCPv6 server assign an address like IPv4 does. You can also do both. You can actually have both. You can have an address that assigns itself and one assigned by the server. And we'll talk about that on Tuesday more, because my Comcast router at home does that. So with all these addresses, by the way, which one would it use? We know that permanent public address, stable address, it's used for connections coming in, but anything going out, it uses a temporary address, right? Slack. If it does not have a Slack address, meaning you got it from the DHCP server, then it will use that address. We'll talk about that on Tuesday too. There's what they call as far as what addresses are used, there's actually a priority, an order. Again, this is one of the things I love and hate about IPv6. Again, I'm not an evangelist. I understand the necessities for it. I think this protocol, if you don't mind me digressing just a moment here, was created back in the 1990s, the late 1990s. Some things were added on a little later, but for the most part, it was, a lot of people, a lot of ideas. They not really thinking, well, they were thinking it, but what I'm getting at is, they had to make judgment calls on what they thought was going to be needed in the future. And this is never easy. And people and there are a lot of debates on all this. Even the early days of, the ARPANET going into the internet from the 1970s into the 1980s, by 1983. The early ARPANET, the way that it used addressing was just a host number, an individual number for each device. And then thought, well, we have to start thinking about, where these hosts are. And that's when we have our current IPv4 and IPv6 addressing structure with networks and devices on that network, a network portion and a host portion. And then just how to reliably send data. The idea of TCP, yes, we need TCP. We need some way to keep track of, did the device get it? What if stuff rise out of order? You sequence numbers and how to let the other device know what it still needs, acknowledgement numbers. So all that came about. What's interesting too is they had the port numbers because they thought, you might have a device. Think about this, 1980s. Okay, there was no World Wide Web yet. They thought, and people were just getting personal computers. Just sorry to go off on this, but I think it's interesting to get perspective with IPv6 as well. You have a host here that's going to connect to some kind of internet, ARPANET, some other devices out here. They have to think about, well, maybe this host might connect to more than one device, run more than one application. Really? We take this for granted now, but back in the 1970s, 1980s, when they're developing TCP, IP protocol suite, that's where they put in port numbers. Maybe this host is going to connect to more than one server. and connected to more than one other computer, running more than one application. So that was the whole idea with port numbers, to be able to differentiate the connection between two different servers. When that TCP segment came in, what application is this going to be for? Or connecting to the same server but running more than one application. So they really had to think ahead. UDP, which is connectionless, which basically they said, is there any time where we may not really care about data being retransmitted? Meaning if a packet is lost, and that maybe just sending the data. And that's when UDP was kind of added on, said, well, let's do this as well, along with reliable communications. Just in case we don't care, let's have a UDP, which is basically, all it did was take TCP's port numbers, and that was about it. So we don't need any of that other stuff for reliability. I talk about this because I find it fascinating, because as we think ahead, we don't know what the future lies. So the developers of IPv6 had to really think about a lot of going on with, that was, think years in advance. See if I can find, let's see if I can find this. It's an interesting, embarrassed is what the guy that created, let me see if I can find, yeah, David Reed.
This is Twix.
This is, so I'm just going to show it. I'm not going to show this video here, but I'll put it on my links here. This is David Reed being interviewed by Simon Phillips. That's David Reed there, in just a couple of years ago. There he was. This is when he was creating soon after, in his younger years, UDP. But he talks about being embarrassed about creating UDP, meaning, yeah, I'm the name behind it. I wrote the RFC for it, but basically I just took what was from TCP and I made the push for, hey, we need something. If we don't want to do reliability, let's still allow, devices to just send data between each other. That's David Reed. All right, sorry about the going off on that tangent. Okay, so router solicitation message. Hey, who out there is a DHCP? Who out there is an IPv6 router? Send me a router advertisement. And here you go. Now remember, when the client sends this router solicitation message, it doesn't know what to expect from the router advertisement. My device connects to my home network, my school network, wherever I'm at, on an IPv6 network. It's like, you tell me what you suggest. In this case, we're going to set the A flag to 1 and the M flag to 1. Oh, okay. The A flag is the default. What if we don't change it and our M flag is set to 1? The M flag is saying, contact a stateful DHCPv6 server to get another global unicast address. So that's where we saw the solicit, advertise, request. So this is just like stateful DHCPv4. The one big difference, and I'll mention this more in a moment, is the stateful DHCPv6 server will never include a default gateway address. That only comes from the router advertisement message. So to set the M flag to 1 in Cisco iOS, we say IPv6 ND managed config flag. Okay, that tells the client to get an addressing information from a stateful DHCPv6 server. Okay, so if we have the M flag and the A flag both set to 1, not just on Windows, by the way, but also on my Mac, and I'll talk about this on Tuesday. Notice that this address here, this one here with _deed, I'll tell you why it got that. But this is an address assigned from the stateful DHCPv6 server. But because the A flag was still set to 1, it created its own address, both a temporary address and a public address from using Slack. So look at that, 3 addresses. Okay, this middle one is the public address. So use that that's used for devices connecting to this device. But here now it has 2 addresses it can use. If the A flag's set to 1, it's going to create a temporary address, and this is the one by default that will always be used. But we may not want I'm going to get to this in a moment. We may not want our devices to do this. If I'm in an enterprise network and I want to use stateful DHCPv6, M flag set to 1, a stateful DHCP server, I want to assign it. I'm doing that for a reason, typically. I'm doing that because I don't want users creating their own addressing. I want to be able to track if we have an issue, who has that IPv6 address. Okay, I'm not going to go back to this. Okay, so why not just disable the router advertisement message? Okay, can we do that? We can disable the RA. But remember, that we don't want to just disable a router advertisement message because that's the only way that it's the only way a client is going to get its default gateway address dynamically. And it's also used to tell the device what network it belongs to. So leave the router advertisement alone. We want it to keep on sending the router advertisement messages. Okay? What we want to do is if we want to use stateful DHCPv6, IPv6 ND managed config flag, we'll see this in a moment, how this device will get its address from a stateful DHCPv6 server. What we may want to do is set the A flag to 0. This tells the device, do not create your own IPv6 address using Slack. So we need to set the A flag to 0. What we do is we say IPv6 ND prefix, whatever is the network prefix and prefix length, whatever is that network address here, we're going to say with this address, no auto config. This sets the A flag to 0. Okay. Or we can also say IPv6 ND prefix default no auto config. So we can do either one. Probably this default's best. Just say by default, set the A flag to 0. That's probably the easiest way to do this. Okay. So what happens when we do that? Okay, we're still advertising the prefix and prefix length. We're still going to tell devices what network they belong to. So they know that's my local network. But we're going to set the M flag to 1. So devices still need that router advertisement message to know, hey, you're my default gateway. M flag, managed config flag set to 1. So it's going to use global, it's going to create its global unicast address. It's going to ask a stateful DHCPv6 server to get that address. Okay, the A flag is set to 0. So Windows, even Mac, Linux now too. If the A flag is, so don't ignore this here, but the A flag is set to 0, it says, I am not going to create my own address. There was a time when even if the A flag was set to 1, if the managed config flag was set to 1, it would ignore the A flag. But no, never. Be explicit what you want in your network. We're in control here. If you want just DHCPv6, set the M flag to 1 and the A flag to 0. This tells the device, do not create your own address using Slack. Okay, so, yes, Pamela.
Rick, would you mind repeating that last statement?
Yeah, no, it's important. you as the network administrator is going to decide, your policy is, if you want to use stateful DHCPv6, so you can track the clients on your network, what address they have, then you probably do not want them creating their own address. So what you want to do is set the M flag to what? This will make them use a stateful DHCPv6 server to get an address. But you also want to do this. You want to set the A flag to 0. Okay, that's because you want to make sure they don't create their own address. The whole idea is not privacy for them. You're in an enterprise network, it's not about privacy for them. It's about you tracking who is doing what in some environment. Okay, maybe, so that's if you want to be able to track who has what IPv6 address. Okay, and this comes with a lease time, just like with IPv4. So, it's not for privacy reasons, it could change once a week, once a day, whatever. But whoever gets what IPv6 address, you as the network administrator, because you're using a stateful server, you can tell, hey, you got this address. Okay, I need to go see what you're doing. Does that make sense? Okay. So here's the, I'm gonna go through this here. All right, let's do it like this. All right, so again, the IPv6 unicast routing command is what sends out the router advertisement. Okay. So what we're going to do is set on this specific interface. Oh, I got gig 0. Got the wrong interface here. We'll fix that real quick. Magic of power. Boy, I can't believe I must have grabbed some old slides. I hope I corrected these. Okay. So the managed config flag says, hey, I'm going to let you know to use a stateful DHCPv6 server. IPv6 ND prefix default no auto config. That sets the A flag to 0. So I'm telling you, don't create your own address. You're going to get the router advertisement with the prefix, but don't create your own address using it. Just get one from a stateful DHCPv6 server. Now, when you go ask for, okay, I won't create my own address. Hey, who out there is a stateful DHCPv6 server? Well, guess what? I'm that server again. I'm acting as a DHCPv6 server. You can have a separate device on your network, computer, be the server, and many do. But if you want the router to do this, now, why would you want the router to do it? Smaller networks, branch offices. You don't want to maintain the server, a separate server. You can have the router do this. Okay. So when it gets requests, hey, who out there is a DHCPv6 server? Again, we are. And the information is going to be passed up to our configuration IPv6 stateful. There it is. Now I named it stateful. Why did I do that? So I know that on this interface, I'm acting as a stateful the router's acting as a stateful DHCPv6 server. Now, notice we said, so this is the prefix, IPv6 ND prefix, no auto config. So here, I'm going to talk more about this in a moment. We're just saying that that this A flag, well, I could have done it one or two ways. Default no auto config, or I could have given this prefix no auto config. So I don't need this if I'm doing this, okay? Or I don't need this if I'm doing this. I could do it one or two ways. Both of these set the A flag to 0. Okay, but let's make it easy. Let's say I'm just using this. a flag to 0. Now, when this device says who out there's a DHCPv6 server, we are. And this is the information we're going to use to assign the addressing. Now notice here, this is the same information we gave us a stateless server. The DNS address, okay, and domain name, okay, just like a DHCPv4 server would get. This is the addressing information. And I'm going to talk about this here. Now, this addressing information, this says as a DHCPv6 server, I'm going to assign the following addresses. Now, I could do this. I could have just made this /64, and that's fine. The server will determine the 64 bits for the interface ID. But I did something a little extra. And this is a little pro tip here. What I did is I said what I'm going to assign is this will be the network prefix still. Because that's our router advertisement says we have a 64-bit prefix here. So this is the prefix of the network. What this /80 means is for the network, for the address that I'm assigning, the next 16 bits, which equals 80, these next 16 bits here, this is the interface ID. 64 bits of the interface ID. But the first 16 bits for the interface ID is deed, D-E-E-D. So every device on my network that gets an IPv6 address, let me state this again. When this router assigns addresses, and that's the key, it's going to assign them. It's going to give it this prefix, and it's going to create an interface ID. It's going to create one, and it's going to bind it to that, kind of like the MAC address, but the DUID of this device. It says, you're going to get this address. But, so I'm going to make the first 16 bits of the address I give you always going to be deed. Now, why did I do that? I didn't have to, but I'm going to explain here in a moment. Okay. I'm going to bypass. This is, okay. So, what I'm saying here is the interface ID by default could be anything of 64 bits that I assign. But what I'm going to do is I'm going to say, no, I'm going to use this first 16 bits of the interface ID, and I'm going to make it deed. So all the addresses I assign are going to have the first 16 bits of the interface ID begin with deed. I think like a deed of assigning it like a deed to a house or something. Did I spell deed right? Maybe I did. Is that right? Deed to a house. Yeah, deed of trust or something. Okay. I'll make sure I spelled it right. So take a look here. When I see a device on my network that has an address, and the interface begins with deed, I know you got that from our DHCPv6 server. This router assigned it as or whatever DHCPv6 server. In this case, my router acting as a DHCPv6 server. This was assigned by the server. I see that and go, I don't have to guess. Did that really come from? I don't have to go and check on the server. Is this one of the addresses we assigned? I can see that. I go, I know that did, because chances are that was not done randomly by this device. My default gateway did come from the router advertisement. However, this address was assigned, and along with the DNS server and the domain name, was assigned by the DHCPv6 server. Let me kind of go back one more. I think I've got it coming up. Yeah, let me kind of show it here too. This is nice for what if I had multiple addresses, okay, but this shows that my IPv6 address, see this deed here? That it was, that tells me, Rick, yeah, you're clever here. You made sure that the first 16 bits of the interface ID included D. So whenever I see that, I know, okay, yep, that was assigned by my server. Does that make sense? That's why I did this. That's why this here was this. I could have, this would have been valid. This is totally fine. Okay. Move this out of the way. This, as a server, I would have just assigned this as my prefix and then another 64 bits. But it would have been hard for me as a network administrator to go, boy, did that come from the DHCPv6 server? This is signing it with that prefix, and here's the interface ID. So this is why I did it like this. So when I see those addresses, when I see this address here, I say, oh yeah, that came from the DHCPv6 server. All right, let's take a look at what the router shows. When we have the M flag set to 1, A flag set to 0, notice now it says host used, this is that show IPv6 interface gigabit 00. Now we see host used DHCP to obtain routable address. Okay. If I did the debug IPv6 ND, I'll see managed address here. I may see, it depends on I might see an M. I'll see L, no A here. If there was an A here, that would mean that the A flag was set. So you kind of got to look for it. And each version, the newer versions of iOS always tend to do these things a little different. So managed address, an M, or that's always the managed config flag. As long as you're not seeing an A here, an A anywhere in here, that means that there's no A flag set. The L means the on link. That means that this prefix being advertised, this device is on that network. Looking at it, in Wireshark, the router advertisement message, there's the A flag. I'm thinking, blah. There's the M flag. I'm thinking, annoying, thinking ahead. Here's my M flag that we set. That's a 1. The O flag was not set. The on-link flag, we don't touch that usually, but we set the O flag to 0. And again, our client, we know that it got it from a stateful DHCPv6 server because we were smart enough to make this 80 bits here, including the deed. So it would grab this 16 bits for part of the interface ID. How we doing? That okay? Okay. So it's not too much different. I think that probably the main thing to remember with stateful DHCPv6, 2 things. 1, stateful or any DHCPv6 server, stateful, stateless, does not provide the default gateway. A client can only get that from the router advertisement, from the post office itself. You don't need a third party to tell you, hey, you don't need your neighbor to give you the address for the post office. The post office will send you the when it sends you a letter. That's something you can trust. Okay? So you have to have a router. You know, your default gateway, to have a default gateway, you have to have a router, right? To have a default gateway, you have to have a router. That means the router is going to just let the router tell you. in a router advertisement, I'm your way out of here. My source IPv6 address of my router advertisement. Don't trust, you don't need to trust anybody else. So that's the one thing. Default gateway address can only come from a router advertisement message. Okay. The second thing to keep in mind is, yes, you can have both Slack addresses if the A flag is set to 1 and a state address from a stateful DHCPv6 server if that address is set, if the M flag is set. There we go. The M flag is set to 1, you can get a stateful DHCPv6 address. The A flag is set to 1, you'll get the temporary and the public address. Okay. Is that fine to do both? Yeah, my Comcast router does that. We'll see that on Tuesday. I'll show you an example, has both. Okay. But in an enterprise network, typically, if we're doing this for a reason to track it, let's get rid of that. Let's set this to 0 so we get rid of these. That's probably in those last 2 minutes there, the most important thing to remember, or to have somewhere in the back of your mind about DHCPv6 stateful. Okay, stateless, not a big deal. Okay, how we doing?
Okay.
When I think about these things and tell you about these things, trying to think about the things that, if I was walking into a company, what are the things that, and they're not going to know that much probably about IPv6, let's say. If they do, that's great. Great to learn from them as well. But if what can you offer? And this is the kind of little tidbits you can offer, remember. So, as they're trying to figure it out, you can say, oh, it's why you'd want to do this, why you don't want to just get rid of the router advertisement. All right, I'll let you go. I will see everybody on Tuesday. All right. Have a great day, everybody. Great weekend.